Everybody okay with 12 electrons since that's what I heard? Yeah. All right, so who would be our central atom in H2CS given that? All right, we all know who can't be the central atom. Hydrogen. So that is C and S, who is farther left on the periodic table. Okay, so how many H's are we putting around it? And how many S's? All right, so 12 electrons, right? So 2, 4, 6, 8, 10, 12. Now.
Wait, okay, how did you get 12?
How did I get 12? All right, so how many H's?
2.
How many C's?
1.
How many S's?
1.
How many electrons in H's outer shell? All right, how many in C's outer shell?
Oh, I'm so slow.
What'd you do?
I don't know.
Okay. All right, but you remember how to do it now?
Yeah.
Okay. So that's how we got 12. All right, so once we have that, what do we remember about H?
It only can have 2.
Can only have 2, so are the H's okay?
Yep.
Okay. Is C okay?
Yes.
Everybody okay with C? Got 8? Yes? No?
Yes.
I got some nodding of heads, and I got a whole lot of staring across the room like Miss Wall's not talking.
Yes.
Yes? Okay. How about S?
No.
No. S has how many on it?
6.
Has 6. Xavier? Are you with me? The king of Miss Wall didn't teach you, so you don't know how to do it.
All right. You want me to tell the truth? I just didn't do it. I didn't do it.
Okay.
I mean, that was pretty obvious.
I know. I just wanted him to admit that.
It's not like I didn't know how to do it. I just didn't do it.
Thank you. Okay. Thank you. Now, so S has 2, 4, 6 electrons on it. It's got to have 8. So since C has 8 and S only has 6, what are we going to do to help S out? We're going to take 2 off the C and we're going to put them where? On the S. So the S has 6, but now it has 8, and the C still keeps its 8, right?
Yeah.
So I kept 12, S has 8, C has 8, H still has its happy 2, right? Everybody okay with that?
Yep.
So how many atoms are bonded to the C?
8.
Atoms.
2.
1,
3.
2, 3. So we got 3 atoms. How many lone pairs are on the C? None. Okay? So what geometry goes with 3 and 0? Triangular, planar. Okay? So tomorrow you got to know that geometry. 3 and 0 is triangular planar.
Okay, so I have a question.
Uh-huh.
We're not going to be having that?
Well, you can leave it in your notebook, but you can't get it out. No.
Did you not have just said no? Instead of saying all the notebooks, you just said no.
No.
Okay, thank you.
You're welcome. Now, the geometry is triangular plane. Is it polar or non-polar? You have to decide if the dipole is equal, and then you have to decide, are there no lone pairs? Now, to decide if the dipoles are equal, are all 3 bonds between the same 2 elements? As soon as you can say all 3 bonds are not between the same 2 elements, the dipoles are what? Are they equal? As soon as you say no to that, it is what? It is polar. Okay? If you meet both rules, it was what yesterday? It was non-polar if you had 2 check marks. As soon as you say no to either one of these, it's automatically what? Polar. Okay? So, number 2 was what? ASBR5. Okay? So, AS had how many electrons?
It has 5.
5. BR has
7.
times 5 is, so 5 plus 35 is 40. So, we're putting in 40 this time. So, AS, and we got 5 BRs. So, this will be an expanded octet. All right, so We got 2, 4, 6, 8, 10. And we just keep going around. And we will miraculously wind up with 40. And everybody's going to have the magic number of what? 8. So, are we going to need a double or a triple bond here? No, it's just done. So, for the geometry, how many BRs do we have? How many lone pairs do we have? None. So, what geometry goes with 5 and 0?
Wait, what's the lone pair again?
A lone pair is dots. Okay, so how many dots?
The dots that's on the central.
On the central atom, yes.
Bi-triangular pyramidal.
So triangular, bi, you can either say pyramidal, or you could be like Samaria over there and say bipyramidal.
So it says.
Yes, if you draw the triangle as a triangular, yes, I would take that.
Great.
Okay. Now, for polar or nonpolar. Number 1, are the dipoles equal? Number 2, are there no lone pairs? So, when we look at number 1, are all 5 of these bonds
Yes.
between the same 2 elements?
Yes.
Okay. Number 2, do we have no lone pairs on this central atom?
Yes.
If you answered yes to both of those, what does it tell you about this molecule? It is non-polar. Okay? If you answer yes to both of those questions, it is non-polar. Okay? All right, last question. Oops, one more. CI4. CI4 has how many electrons? 4 for carbon. 7 times 4 is 28. 28 and 4 is, so C, 4 I's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 32. All right, so when I finish drawing that in, does everybody have 8? Yep, everybody's got 8. I got my 32, so do I need to move anybody? No, I don't need to move a soul. Everybody has 8. How many eyes do I have? 4. How many lone pairs are here?
0.
So what geometry am I if I have 4 and 0? Tetrahedral. Okay, tetrahedral. Now, this last thing I need is, are my dipoles equal? Yep. Do I have any lone pairs?
No.
So I'm what? Non-polar. Questions?
No.
Everybody there?
Yes.
Fabulous.
Are we gonna go over our home?
We are.
Oh,
right.
Miss Wall, I have a
Yes.
question.
What opening are we on, by the way?
That was 6.
That was 6, okay. Yes, what is the question, Sophie?
Thing it says describe the chalk.
Oh, yeah. Anything that involves the senses except taste. So color, shape, texture, smell, anything like that.
I have a bigger stove.
He's the
biggest stove.
Yeah, I'm too big for this.
I don't know what to tell you.
Okay.
You can sit in one of the multiple chairs that I offer. Yes.
Oh, okay.
Yes.
Oh, no, she can stand up now.
You know, Walmart only sells jade-sized stools. I can't fix them for you.
My thighs.
Okay, they're picking up just a little bit.
Yeah, y'all.
All right.
Think on y'all be thicker than Jaden, and you gonna be mad. You gonna be mad. Y'all all gonna be mad.
I'm mad now. Why would I be mad then? Right. I ain't mad. I love my son.
Haters.
Can't fix it. The
No, y'all
Walmart
gonna be
only
hating on
sells
me.
jade-sized stools.
They gonna be hating on me this long when I get thick.
I'm sure they will.
Yeah, they will.
All right. So,
You still little.
Boy, no.
if you look at the way I've done the paper or the assignment up here, the left answer is the bond type, the middle column is the Lewis structure with the geometry, and the far column is the molecule type. Now, the one I have labeled as the exception, I will talk about here in just a second. Just check the first 3, and then I'll come back and talk about that one. Shouldn't take but a minute. Those of you who didn't do it, I'm not gonna waste my time waiting on you writing stuff down, so.
Oh, I'm done. Yeah.
All right, have we had a chance to check? All right, if you look at the second one, all right, most of you probably, who did it anyways, said that it was a polar molecule because it had lone pairs, right?
Yep.
Now, look at what you got when you subtracted over here. This was 2.1 minus 2.1. So when you subtract, you get 0, right? You can't be polar over here if you get what number? 0. In order to be polar over here, you have to have a difference of at least what number? You got to have at least 0.1. Okay? If you get 0 when you subtract, you cannot be polar over here. And it doesn't matter that you have lone pairs here. If you get 0 on all the bonds, you're going to be nonpolar. Okay? Those pop up every once in a while, but they're incredibly rare. There are actually 2 of them on this worksheet. You will not see me give them to you very often. Okay? Huh? Anytime you subtract the electronegativities, if you get 0, it doesn't matter how many lone pairs are on it. You will be a nonpolar bond and molecule. Okay? You have to have an electronegativity difference in order to be polar.
What's polar mean?
Polar means that your electrons are not shared equally.
I wrote this down.
That's good.
It was,
It's
three.
from language and.
I used to encyclopedia to look it up.
You have it in your notes.
Oh,
We already talked about it.
oh.
That's why you should put on some bird mix for it.
I should put on some what? I thought I would wear it tomorrow with my Tide shirt.
Because everybody in here got bird mix. Sophie got on some, Jay got on some, everybody.
Andy got on
Leah
some.
I got on some.
And you got on.
So. Okay, me. I'm gonna talk to you.
I have someone too smart.
All right, any questions on those?
No.
Okay. So other than the ones that turned out to be 0, we're doing okay?
Yeah.
Okay. Oh, you can just put polar, that's fine.
I have a question.
Yeah.
Why is the one CO2, why is that not polar?
Because the bonds are the same, they're both CO bonds, and the dipoles are equal, and there's no lone pairs on the C.
Why did you put non-polar covalent?
Where on the last one? Have it. It could just be NP.
What about,
It doesn't have to have a C on it.
HBr, why is that polar?
Because anytime you have just one bond, there's no central atom. You just
I
subtract.
forgot about that.
So even if there's like a double bond, it would be non-polar.
Yes. Yeah, the same rules apply. And it wouldn't even matter if this one, for example, if this one had, let's just say this one was a double bond and this one was a single bond, it would still be the same. This is still CO, this is still CO, and there's still no lone pairs right there. Now, let's say I had lone pairs there. Then it would become what? Then it would become polar because I had lone pairs. Okay, but if I didn't have lone pairs, then it could still be nonpolar. All right, can I turn the page? All right, last one. Now, the one at the top is nonpolar for the same reason pH3 was nonpolar. When you subtract, you have 3.0, subtract 3.0, which is 0, which is why it's nonpolar over here.
Why is
Okay.
the last one polar?
Why is the last one polar? Because it's one bond, okay? That has no central atom. It's one bond. It has to have two bonds to have a central atom to use those rules. Anytime it has one single bond, okay, one bond, the bond type equals the molecule type. Okay, because if there's one bond, that means there's no central atom, right? Because this has no central atom, right? Can we agree on that? So if there's no central atom, how would I decide how many dipoles there are and if all the dipoles are equal? Well, there isn't a central atom to make sure all the dipoles are equal, right? So whatever this is, it's going to be the same there. The bond type will equal the molecule type. Any other questions? All right. Since I have to take third period to that stupid expo, excuse me, I should
Career fair.
Oh, we
It's
go.
out in the gym.
Hey,
Hey.
What period?
I'm supposed to be cooking here this morning. Oh, you won't go.
You're going to take a minute
Y'all will have
to practice for our quiz.
Y'all probably gonna be clicking for every year.
I know, but she wasn't here yesterday, and we were supposed to cook for them yesterday, and we're supposed to cook for ourselves today. So we're cooking for ourselves today.
Little cook for me.
What's your baby?
Some chicken fritters. I
Chicken what?
don't
Now,
I don't know what it is.
your homework? Let me see. All right. We are not going to take very long to do this, okay? Because I'm not giving them very long with that expo. Because most of them are just going to wander around aimlessly and do nothing. So,
You about right.
I know what most people do in those things. So, we're going to take about 10 minutes. Do as many as you can before I stop you.
Yeah.
But no, I don't care.
Okay.
You can be Xavier and claim I didn't teach you.
I own up to it.
That'd be great. I'm getting ready to put that else, I put the other in.
I just put you out of your misery when I want to.
So you didn't see? And she was just very honest. But then I tortured her and told her I'm going to email Ms. Burton, and then we'll see how well she does with tonight.
It was her fault.
It was Ms. Burton's fault you didn't do
Yes.
your homework?
Yes, because she had us here until like 7 something last night.
Jackie didn't post hers?
You had to be the, but she didn't do Jessica's homework though, which is her A push homework. What happened?
Man, you just spilling out.
So,
Right,
yeah.
why you just put my
Oh, yeah, that is not your play. She said she was like, you know, Ms. Burton because they didn't do my homework.
And so you won't go me?
Yeah, but that's it.
What is wrong with you?
She was quick to throw you under the bus.
Jay, we gonna have to.
She was quick to throw you under the bus. Although, you know, Jay didn't do her chemistry homework either, so.
I didn't say nothing.
Are you a project potential student today?
I had to work, like,
You pour mine in your bed.
I'm coming for you.
Yeah.
I'm gonna knock them highlights out your head.
Oh, no, she bad with her.
Oh.
She gonna be back to the same old.
She gonna be in.
You been sloth again.
She still is a slothful highlight.
Yes. Is there a reason why we did the geometry on the first time?
That one cracker yesterday. Oh, Jay, that's all her.
You get 100 on yesterday.
But
You get
she said something about the
80
slave.
for
I
the
said, oh, so.
I know you hear you got back.
Yourself.
And if you want to see the answers to the homework, it's there. These are arrows. You click back there. You can check.
You want the cookies?
Yeah, I do.
And that just leaves you with yesterday's quiz to make up. All right. Who has a question?
Oh, Lord Jesus.
That's what I do with it. There it is.
Thank you. So these are the stack of papers. I've yet to read.
JD 4 5.
What are they going to do?
You can remember.
Yeah, I just did. Hey. No, because when I want homework, y'all.
I always do my
Negative.
homework, but you never do it yourself anyway, so it don't matter.
I did.
Girl, I've been doing my homework. I be asking y'all for help, and y'all don't never
I
help
be
me.
helping you.
Ooh, shut up.
Y'all are like a band of thieves ratting each other out of here today about who doesn't do homework.
No, because I be asking them for help, and they just act like they can't help
They be
me.
ignoring you. I be the one sitting in the message back in the group chat.
Mm,
You
Y'all
can tell
have,
me.
we had that behind y'all, so we can't even give us y'all homework.
Whatever.
I ain't
Y'all
talking
do
about
y'all do my
homework. I
practice.
be doing
Stop
my
yelling.
homework. I'll be doing this.
Stephanie.
There ain't no point.
Did you?
Oh, but he take it up though.
So you could check it and see if you wanted to see the answers. Just go up there to the lectern and
Oh, shoot. man.
click through it if you want to check your answers.
I always forget this night.
I did.
Yeah. I forget this one.
You have a question?
No, I'm missing some for the second half.
I just,
Yes, ma'am.
I'm gonna quickly grab those first.
So if you wanted to do this, for example, you want to know bond type. Look up C and look up O. Oh, it doesn't matter what the subscripts are. All right, let's see. Let's see. Subtraction. All right, use your phone. Subtract. What do you want?
I wonder if, dude, I really wonder if this client is gonna take this.
You get one.
Now that she is.
Wait, what are we doing in legends tomorrow?
Don't worry about it, do mine.
We're going over
crowd
quiz.
That, we're going over the test.
Oh, the quiz.
And I thought she said the practice was,
Okay.
we had it yesterday, but I thought it was Friday.
I thought it was.
I did too this
How are we having our vocab quiz? We ain't even done the.
Y'all want your quiz for me today? It's already run off.
No.
You do my assignment.
I'm really
We haven't
over
done that in our class.
Do it with less verbiage.
Miss Wall, you get a check.
Calm down, Miss Wall. We still doing our work. Got the first
It's
one.
okay. Right.
I'm getting grumpy.
Don't get grumpy, don't be distracted.
Okay, how do we determine the polarity?
Yeah.
Don't put it right there.
Does
No,
it
she's
have,
not really grumpy, that's funny.
So.
does it have the same
Oh,
element going around?
That's a good class.
Yeah. Does it have long hair?
No, I don't have one.
That's
Okay, does it
right.
have the same element going around it?
Yeah.
I think that's what
Okay, so it's not
you're allowed to get.
Oh.
It's non-polar.
Take 2 out and fix it.
So if it has a lone pair and it has different elements going around it, it's polar. So we can only use polar and non-polar. Okay.
Yes.
Okay. Is it that?
Are those there or gone? 2, 4, 6, 8, 10, 12. You still have 12. I don't know, but you got 2 too many. You're right.
Whoa. Okay.
Okay, I have a stupid question. Can you have allergies without being allergic to anything?
Yes.
No.
I think I got allergies.
Because I mean, you can have allergies from like the pollen.
You're allergic to it.
That's what.
You know what I mean? But a lot of people are.
Miss Wall, answer the question.
You can be allergic to pollen.
I'm going with Tomas on this. I would say no. You're going to be allergic to the stuff that's in the air. Pollen, the other stuff
Some
that is
people don't
around.
react to it. They're not allergic.
Right. Like, most people are convinced that I have no allergies to poison ivy, poison oak, or anything like that, because I've never broken out from any of that stuff, and I've worked in the yard my entire life. But I've never gotten a poison oak or poison ivy rash, ever.
I think I'm allergic to pollen.
And it could be I just never touched the plant. but people find it odd that I've never broken out in it in my entire life.
Alright, we should, the test that has.
Let's not. I don't want to
But
test.
I thought you only get if you're allergic to it anyway.
Right,
Oh.
right. That's why most people think that I'm not allergic.
She's like, I'm probably do that.
That's what I'm gonna do.
So,
What's up,
I keep getting colds. Do you think I'm allergic to something? I think I'm allergic to pollen.
You could be.
Hey, give me.
All right. So you've got 2, 4, 6, 8, 10. Now you've got 10.
Well,
Now, I know, but Anna only has 6, so now help Anna out. And you're almost there.
Yeah, I said.
Okay. Are
All
you doing
right,
that?
so
Okay.
now it's right. So now what's your original question?
Oh.
Yes.
Okay, I have a question.
Let me get Justice on you right there.
Some more.
She asked me a stupid question, that's another question.
Yeah. So H
That's
can't
what
be
we
in
asked.
the-
When you see it in
No, because you don't have enough.
Oh, that's what it is.
So Jay, is he just gonna take it out or is he gonna
Okay,
like?
have y'all done the second?
Yeah, I finished
I'm mixed.
Now fix it.
So do we just add 2 dots?
All right,
down
good.
here? I don't have no question.
You come here after her, number 2, this triangle.
No, because it has long pairs, so it's 3 and 1.
It's not hard. I finished that one sheet.
I'm gonna use the other sheets.
It's not, it's just a problem of time.
Okay. Who else?
But it's gonna change in the other case.
She said we can call this one the mafia.
Bipyramidal would have 5,
Oh,
so that would just be regular pyramidal.
Andy, what are you saying?
no, I can't.
I'm talking to myself, man.
Are we good? Questions?
Hey, it's 3 triple bond.
I answered everybody else's question.
Okay. I guess, I guess.
Is it?
Yeah.
Now, bad is just, maybe because,
They would have so many.
maybe it's because.
It's gotta have
Oh.
8. Make him have 8.
Jay, you working that?
That's C,
Yeah.
Oh, nothing.
okay? Doesn't have 8.
Like tomorrow?
Take that off. It's only 16.
You said you gotta have 8.
Gotta have 8. You can't draw more in. You can rearrange them though.
Hold on. So it's 10 to 1. Oh, we got that.
No, everybody has to have 8.
Me and
So
Alfie
how-
was gonna pedicure tomorrow, but I don't know.
So when you add
We
those
just-
up,
we were
you
just
got
talking
16.
before,
You
my
got
little
16
twin
going
had-
in. But now that you've drawn 16, you gotta rearrange them so they all have 8.
Oh, we-
Okay?
right
Now that one
after-
has
right
6.
after we get
And that one has 6. Okay? Now that one has 8 and that one has 6. So when you move them, you gave that one 8, but now that one only has 6. So where can you move them so this one keeps its 8 and that one keeps its 8? Instead of putting them there, put them here.
So this is 2.
Yep. So you moved them there, but you gotta erase them. So now you still have 16. 2, 4, 6, 8, 10, 12, 14, 16. You still have 16. Now check to make sure you have 8. 4, 6, 8,
Cause you
2,
said all right,
4, 6, 8, 2, 4, 6, 8. They all have 8. Right, you gotta do that on each one. So like here, 2, 4, 6, 8, 10. You drew in the 10 and flat. Now, H has 2, it's only allowed to. This one has 8, and that one only has 4. So you gotta have 10, at end, help C.
So that's 4.
Now that one has, now this one has
This one.
2, 4, 6. Both of those go to the C. Okay, but his N has 2, 4, 6, 8. So N still got 8. The C only has 6.
It depends, like, if it's anybody else, I don't have to react, but like,
Yeah.
That's like you and
Right.
Ethan. I love those. I
Now,
love
this one, you
those.
draw all the elements. You have how many H's?
And Jay.
Oh, two.
Jay,
So, take this off. I'll leave that on there.
how I get on your nerves.
That,
I'm
now
getting
counter
really
2, 4, 6, 8, 10, 12. Take 12. No, electrons. You counting your electrons?
See, what I was doing, I forgot everything that.
You gotta total up the electrons first. Now help me get it. Polarity, all the bonds, the same. And no, pairs, simplify.
You gonna play that song,
You
Bill?
can see, all four of these bonds, the same two elements.
You gonna play that song, Bill?
Are these bonds right here between the same two elements. If they're the same two elements, bonds are the same. No lone pairs on C. You meet both of those, it's non-bands.
No,
So what?
I got all these.
Yes, no. No lone pairs, so you go 2 and no lone pairs on C. That's 2 and 0. Yeah, you don't have any dots on C. Yeah, when you have no dots, it makes it linear. If you had dots, then it would be bands.
Okay, and if it's automatic, like if it's three elements, if it's three letters, that means it's automatically.
Linear or bands?
No, it's not a what?
What?
Like. The polarity. I don't know what that means. Like the two elements are all the bonds the same time.
Yeah, if they're the same two elements, so like, see how it's C and CL, C and CL, C and CL,
So like
C and
CH and CN. That's what.
That's automatically different.
I'm
Correct. Okay, so this has 2 and 2, those are good. This has 2, 4, 6, C's good. Bless you. This one has how many of them?
That's great.
That makes 6, it's got an 8.
Man,
So you
come
got
on.
help. Who has 8? Because that's the rule, it's called the octet rule. Everybody gets 8.
Come on, put that.
So, you can help O get 8. Who's the only one on there who has 8 that can help O?
Oh, you about to
So,
come bother me.
O get 8. Yep. Same thing here. 2, 4, 6. C has 6. Who has 8? C.
Okay, well, you don't have to attitude with me, okay? Period. I'm gonna take the glasses and
Oh
step
my
off.
God.
You come here.
Then you're gonna be mad when the glasses this morning, man.
Draw 2 extra
Oh,
dots.
man.
Free so. That'll solve everybody's problem. You drew in 10 electrons. 2,
What's that?
4, 6, 8, 10. You drew in 10.
Jay,
You drew out 2, 4, 6, 8. 8 are here. This one only has 6. Again, that's to help out C.
No, thank you.
That's the way I want to.
Is that what?
Always.
No, you cannot draw any more dots.
I don't know.
What is this? Like, First, it's so long. First, I think I might do it.
Here.
What time are you getting it?
So now you have 2, 4, 6.
Yeah, I wasn't going to.
I'll make a mess well.
2, 4, 6.
I'll probably get my hair done,
Yeah,
like.
So start one. Okay, we just haven't drawn a lot of them.
Actually, no. I'll get my makeup. I mean, I'll get my hair done after I get my
Come
makeup
here.
done. All right, I'll have
I'm getting my hair
So,
done.
you can only be.
And I'm just gonna have her get it up.
My girl, it's gonna be
Yeah.
a bonnet until we.
I'm putting a plastic bag.
Bonds have to be
Yeah,
decided.
that's give me a.
Is this between the
Trying to
same two
get that
elements?
llama up.
And this between
I
the
got
same
me
two
a
elements?
then I got me
Yes.
a silk
Does
wrap.
the apples
Oh,
equal?
my God.
Are there any lone pairs on C? It's non-polar.
Yeah. I just want to throw a mark for the
I'm gonna
ones
bring
that
my
have
girl
lone
on
pairs.
camera and look like a picture.
Oh.
But somebody else.
I didn't know what else to do
I don't know where.
Gotcha. All right, I know the first one is CO2. You could have drawn CO2, except that my dots are connecting. This way. Or this way. That has a name. What's that called? Start with an R. Does anybody remember?
Right.
It's called a resonance form. Two different ways to draw the same structure. It's called a resonance form. All right, what's the geometry? Linear? Is it polar or non-polar? Non-polar. What was the next one? pH 3? All right. Geometry? Triangular?
Planner.
Pyramidal.
Oh,
It's pyramidal because it has what? Lone pair. Planar would have no lone pair. Polar or non-polar? It's the exception you just did in your homework. 2.1 minus 2.1 is 0. All right, next one.
So it's not.
This one is
Number two.
this is the exception we just did in the homework, folks. Okay? When you subtract the electronegativities, if you get 0 when you subtract, it's non-polar. The odds that I will give you an exception on the quiz or the test are minuscule, but that is one of the exceptions. Okay? What was the next one?
HCN.
HCN has a triple bond. Looks like this. What's the geometry? Linear, and is it polar or non-polar? It's polar. The reason it's polar, for those of you who don't know, is this bond and this bond between the same two elements. It's automatically polar. The dipoles are not equal if those bonds are not between the same two elements. All right, number 4. What? The geometry is linear because there's two atoms. There's an H and an N. And are there any lone pairs on the C? No, so 2 and 0. All right, what was number 4? H2CO. All right. How many atoms are coming off the C? 3. 3 and 0 lone pairs would tell us the geometry is what?
Triangular plane.
Triangular planar. Is it polar or non-polar? It's polar. Are all these bonds between the same elements? No, that's why it's polar. Dipoles are not equal. All right, the next one. SF2 has 20 electrons. All right, SF2, what geometry is it? Bent. It has 2 and 2. Is it polar or non-polar? It's polar. Guys, got lone pairs. Number what, 6 or around 5?
6 is PCL.
Is what?
PCL.
PCl3 has 26 electrons. All right, what geometry is it? Triangular pyramidal, and it has, it's polar. Next, CCl4 has 32 electrons. It is tetrahedral because it's 4 and 1. And I heard somebody yell out it's nonpolar. So tetrahedral and nonpolar. What's the last one? N2O is what? 16 electrons?
Yeah.
You can draw it like, oops, that. Hope if my dots would work. Or you can draw it like that. Again, it's a resonance form. Either one is acceptable. What geometry would it be? Linear, and it is nonpolar. The bonds are both between O and N on both sides, and there are no lone pairs. Any questions about how to do that? All right, that is your quiz tomorrow. You should be able to do that when you get here. You should. You cannot use your notes on the geometries.
Oh, man.
Just saying. All right.
You giving us a
Oh, man.
I'm giving you a quiz paper. And you may use your electronegativity table. That is it.
and our blue sheet.
There is nothing even remotely helpful on that blue
You said we
sheet.
use our blue sheet on the quiz.
No. It is not useful on this quiz, so you may not have it out. Yes, my dear. Yes. I drew it straight. You bent it. It is the same structure. All right. We're going to switch to ionic bonding. Now, when we started ionic bonding illustrated, covalent bonding, when we started that, I guess it'd be about 3 days ago now. 3 days ago, what was the key word I told you had to remember with ionic bonding, or covalent bonding? You had to remember shared. So when you drew Lewis structures for the last 2 to 3 days, and when we talked geometries, we were illustrating shared electrons. So in a minute here, when we move to ionic bonding, can we draw a Lewis structure? No. Lewis structures are strictly for what? That's right. All right. Lewis structures equal covalent, which are shared electrons. Now, given that we're going to talk ionic bonding for the next 15 to 20 minutes, are we going to be talking about Lewis structures for the next 15 to 20 minutes? No. We want to find a way to illustrate ionic bonds that show what? What do ionic bonds do? What do their electrons do? They gain or lose. Okay? In ionic bonding, electrons are lost or gained. The other definition I gave you is the electrons are transferred. Okay? So, essentially, one atom is going to give it to another atom. So if that's going to happen, we cannot draw a Lewis structure because Lewis structures show sharing. Now, ionic bonds can be illustrated in a chemical reaction type structure. Okay? It's not really a chemical reaction, just sort of looks like one. All right, has everybody caught up? All right, so to illustrate this, a nice, easy ionic compound that we can all talk about is salt. Okay? Now, on the left side, we show the electrons in their original positions. It's essentially a dot diagram. So, what group is it in? So how many dots would it have?
We had 2 or 1.
I hear 1 or I hear 2. One of those is the right answer. Is in group 1, so it has 1 dot. All right, chlorine is where? Group 17, so it has how many? Okay? Should we have forgotten the number of dots for a dot diagram for the test? No, we should not have, because you will see that on the next test. The next test could be as early as Monday, by the way. Depends on how far we get today. Probably going to be Tuesday based on the fact that I got to take third period this stupid expo. All right, so on this side, we show where the electrons went. Okay? So, what do we know sodium is going to do? It's going to do what? Okay, yes, it will. It will explode in water. It will. I just want to know what's going to happen to its electrons. Remember, we're illustrating what happens to the electrons. So sodium's going to do what with its electron? It's going to, which one? Lose or gain? It's going to lose, okay? So we know, Na will lose. And we know Cl will do what? Will gain. So the question is, how do we illustrate that? What are you going to do on this side in all your examples for the element that loses and for the element that gains? Draw all the dots on Cl is correct. Okay? So we draw dots on the element that gains. Only. Okay? So, dots that gains only. So, chlorine has how many to start with?
7.
And it's going to gain how many?
1.
So, it's going to wind up with 8th dot on chlorine. That's one thing we're going to do. We need one more thing to illustrate that Na lost and Cl gained that we already know how to do. Okay. I can write that down. Okay. All right. No dots on element that lost electrons. All right. No dots on the one that lost. So that still doesn't answer my question about what's the one thing we still need to add that y'all already know how to do. The what, Justice? We're going to make it an ion. So what do we got to add? What do we call those? Well, there are polyatomics. These just aren't polyatomics. Well, those will become cations and anions, yes. But it's another word we need. O. Yes. Okay. We're going to add the oxidation number. Okay. So what oxidation number will Na get if it lost one electron? +1. And what oxidation number will Cl get if it gained one electron? Questions? It's not hard, is it?
So it's gonna be formatted like that, like the beginning, and we're gonna have to figure out the end.
Mhm.
Not figure out.
Yes. Figure out the end. You said it right the first time. All right. Everybody with me? Got what they need off the board? Okay. Because now we're going to do one that's not quite as easy.
What time is the career thing?
Depends on your third period class.
You don't go during your lunch period.
If you have third lunch, you go at the beginning of class.
So,
I think second goes to the third.
wait,
I can't remember. I'd have to look at the schedule.
we don't look for it.
All right. So let's say we have Mg plus Cl. I would anticipate that at some point before the end of this class that there will be an announcement. I can't imagine that Ms. Curry will not speak to us before the beginning
bet
of
she
the
won't.
expo.
I don't think she will.
I bet she won't.
Yeah, she will.
We could hope. All right, so if we have Mg, how many electrons does magnesium have?
2.
Got it.
Oh no, I already see it.
So we're going to put a 2 here.
Wait, what question did you ask?
I said how many outer shell electrons does magnesium have? People yelled 2. All right, and how many does chlorine have?
No.
I know she's the one who
All right, so if we look at that, what's going on?
That's gonna be 9.
CL go get it all, and then MG go have it.
MG's going to what?
Have one.
All right, can MG only lose 1?
Oh, no.
They're not there yet.
So is MG gonna gain them?
MG's going to react with chlorine.
Dang
So
it.
is MG gonna gain them?
MG has to do what to be happy?
Lose 2.
Got to lose 2. Okay? So if it loses 2, what's its oxidation number? Plus 2. How many is chlorine going to gain?
One.
Going to gain 1. So it now has how many?
8.
And we have this one floating around out here. Can we have one electron floating around in space that didn't have a home? No. All right? It's got to have a home. Okay? No homeless electrons are allowed. We have to add something to that product side to give that electron home. We have to add an element to give it a home. Now, our options are either an Mg or a Cl. Now, if we add another Mg, for obvious reasons, it's going to do what? It's going to lose 2 more, and we're going to wind up with how many homeless electrons? 3. Are we fixing our problem? No. So do we want to add another Mg?
So where you get that from? What you just do? What you just do? Oh, what you got?
I said we get to add either an Mg or a Cl to this side because that homeless electron has to have a home. So my point is adding a magnesium going to benefit us? Because if we add Mg, what's it going to do? It's going to do what with those two electrons? It's going to lose them, and now suddenly I have how many homeless electrons? 3. Do I want 3 homeless electrons? No. I want to add whoever can take in that homeless electron. So who can gain an electron? Chlorine can gain an electron, right? Because chlorine has how many to begin with? It has 7. And then this number 8 that's just roaming around out here in space is homeless can just do what? It can just join it and move right in. And then it also has a -1 oxidation number. Now, every electron has to have a home.
Yeah.
It can't be given off in space.
Where the other CL come from?
These two right here. You can have as many Mgs and as many chlorines as you need so that when Mg gives up these electrons, they have homes. Nobody said that we could only have 1 Mg and 1 Cl. Okay? So if I give up 2 electrons from Mg, both of them can't go to 1 single chlorine. So on this side, those 2 electrons are going to need more chlorines. You can add on this side as many chlorines as you need so that both those electrons have homes. So in this case, we need how many chlorines for those electrons to have homes? 2. So I added 2 chlorines. Okay? Now, I know you come in tomorrow and tell me I didn't teach it.
Now,
So-
I'm coming tomorrow morning. You got 2.
I don't have duty this semester, but I don't get here until about 8. Now, is both sides balanced?
Yes. No.
I have failed.
No.
No.
They're not.
How many chlorines are on this side?
2.
How many chlorines on this side?
1.
So what am I putting here? Yes, you have to balance.
Why?
It's been a minute since I had.
Well, you know, we need to practice our skills and make sure they're up to snuff before we get to the gas laws next week because we're going to have to balance again.
What?
What? Balancing is not gone for the year. Oh,
Miss Law, do you have any tissue?
right there. All right, y'all try that one. See what you can do.
No.
Yes.
We know the chemistry video.
Anytime I can be helpful.
How is
I
that
didn't choose
helpful?
Somebody said that they wanted to fail chemistry. I said, anytime I can be helpful.
No, I said, here we go, we'll fail it again. Because I can't do it balance.
Oh, that ain't good.
That was close though.
You just now figured it out?
What?
But it's like each time I look in the mirror, I feel like I'm little.
Last time.
I didn't thought y'all I don't know, but you can talk. I was like, you be trying me.
I got a snotty nose, and it's just my right nostril.
That's nice. At some point, we need to just stop.
What?
It's too much information for the rest of us.
It's not. Close. It's not.
That was so
You felt the need to share all of that information.
I need to use the bathroom, but
Okay, you go into the bathroom.
I have a pee.
Why?
Okay, I was like,
everybody says I gotta go to the bathroom.
do we,
Shut up.
we have to put the dots around it.
Yes.
Okay.
We don't have to. I just mark it wrong.
It has become everyday.
Jay, they should go, Jay, they should go next to your question along with it.
We have to say that last part.
Right.
You could have just
You could've just said,
So, yeah.
yeah, we gotta pick it out from there, and that conversation would have ended.
efficiency. And you,
Yeah.
table up there.
My mama always ignores me.
No, she just don't text nobody back but Jerry.
Right. Let me tell you about when I was in a McDonald's today. So I was, her car was parked right there in the front. And she's sitting there scrolling on Facebook. So I'm like, I forgot what she wanted to eat. So I'm like, okay, I'm gonna call her. I call her, she sent me straight to voicemail. So I'm like, all right. I call her again, straight to voicemail. And then I look at her and she's looking at me and I said, answer the phone. And she said, and I called her again, she said, bruh. And started scrolling through Facebook again.
What's up? Don't make no sense.
That's why her food was wrong.
All right. So how many dots do we put on K?
She does
One.
One. How many do we put on O?
6.
Okay. So, given that information,
Because all of you gonna be this
There's
easy.
gonna be 2 pages.
huh?
It says all of you gonna be
Yeah.
this easy. Oh, sweet.
All right. So
What's the catch?
K is good. It's always a catch. You sound like Jake now. All right. So K is going to do what?
Lose.
Okay. O is going to do what?
Game.
Okay. So O has how many? Has 7, right?
Yeah.
So is O happy with only 7?
No.
No, it wants how many? It wants 8, right? So K has to do what? Add another K. All right. So that one goes there, and you wind up with a -2 there, and then you put a 2 on the K. Now, some of you may be sitting out there going, I don't have any clue how to do this. Want a shortcut? Figure out how many you get over here. All right, tell me the oxidation number of K. Tell me the oxidation number of O.
You know, Chris, man.
I am. How many K's do we have? How many O's do we have? How many K's are up here? How many O's are up there?
Oh.
So if you get stuck and you can't figure out how many K's or how many O's or whatever number of whatever I need over here, you can figure it out by using what we already learned this semester to figure out how many of each element you need
That works
every time.
even with.
All right, for example, let's say I ask you to do this one. All right, do that one.
You said, let's say.
Let's say I ask you to do that one. Like,
So
do
that's
it.
being theoretical.
Do it, not theoretical.
Oh, sorry. That's so theoretical.
Theoretical.
That's a lot.
What?
AL is,
Okay, and I have a question.
Okay, what's the question?
So when we're drawing our dot, are you gonna take off if we don't? Never mind. I didn't want to.
It would depend on my mood and whether I was feeling kind and gracious.
What was that going
Can we
to
reduce?
If I would take off if you did 2, 2, and 2, or if you did 2,
Yeah.
2, 1, 1. Mind reader.
Could you not, because you know what we talk about, we know what we talk about, so why would you?
Should we reduce the numbers?
Oh my God.
Reduce what number?
Like, there's 6.
Oh, I know.
and there's 3.
How?
And then, like you said, when it puts you on.
600.
What? I'm talking about. Oh, oxidation number. Are you supposed to use oxidation? Oh, okay, I know what you're talking about.
You got quick file.
And you can, you can only add one of those 2 elements that you already have, or,
You only had L or O.
Okay, I got it.
So would the dots be 3 and 6?
Yeah.
Okay.
I think I did this right here.
Are we done?
Yeah.
Okay. So how many dots you got on L?
3.
Okay. And how many do you have on O?
6.
6.
All right. L will do what?
Lose the tree.
And O will.
Here.
So it takes 2 of the 3, and then you have 1 left over. So O can take 1 of those. That only gets you to 7, right?
Add another
So you add another AL. It takes 1, and then you have 2 left over. So you add another O, and it will take it. So you get 2 here and 3 there. Now, if you were struggling to figure that out, AL has a 3, O has a -2, 2 comes down, 3 comes down. How many AL should you have had?
2.
How many O should you have had? 3. Okay? So I said, this will always work for you if you can't follow the number of dots. Does that make sense? Yes? No? Okay. Y'all are saying that like, yeah, but well, I got it. And then I'll grade a quiz like yesterday and be like, holy crap, they didn't have it. All right? Some of y'all were with me on that bond type stuff. And some of y'all were in left field. In case y'all hadn't checked Power School.
Well, at least it wasn't a right field. What if it was a right field? That was right, Tiffany.
For example, were you supposed to just write covalent for bond type?
No.
Were you supposed to just write polar or nonpolar?
Check my grade.
Were you supposed to write just polar or nonpolar?
No.
No. You had to write polar covalent, nonpolar covalent,
Oh, I was like,
metallic,
I did
or
that.
ion.
Oh.
Okay? You can't just write polar. Polar is not a bond type. Br2 was one of the most missed, or Cl2, I don't even remember which diatomic I had on there, but let's say it was Cl2. All right? Do you know how many people told me this was an ionic bond yesterday? I lost track of the number of people who did this. All right? Y'all looked it up on your electronegativity sheet. Wrote down whatever the electronegativity number was. Okay, let's just say it's 3.0. All right? You looked it up on the scale and you said, whoa, that's ionic. No. And you jacked it up in the remainder of your questions. Okay? This is not an ionic bond. What do you do with Cl2? You got to look up and remember, we don't write this as ClCl. Okay? Because it's diatomic, it's like writing it like this.
I think you put the wrong grade in.
We can look at it and see. So 3.0 minus 3.0, and we get what? 0. So this would have been what kind of bond? Nonpolar covalent. Okay? I even told y'all can abbreviate NPC. Okay? But I got a whole bunch of that was that. What type of bond did I tell you you couldn't put in the list of increasing covalent or increasing ionic character? Metallic. Okay? So when you got to whatever the metal was, and I don't remember what metal I had, let's just say it was iron, because I have no idea which one I used. All right? So if you look up iron, and it was 1.8, what do you suppose people put for that one? They sure did. They wrote down ionic. Okay? They looked it up on the electronegativity table and they said it was ionic. You can't do that either. If it's just one single element and it's a metal, you're supposed to write down it's a metal. You don't use its number and it doesn't get used on the scale from 4 to 0. You have to leave it out. Okay? What if it's what? Such as, you wouldn't have Cl by itself because it'd be diatomic. You won't have one of those. No nonmetals by itself. Nope, P will not be by itself. It'll be in a bond. Okay? Now, and I'll hand those back to you tomorrow. Now, looking at properties of bonds, we're going to look at ionic, covalent, metallic. And the way I usually do this is I make one board, like a column in a chart. I will tell you, if you write really big, you're probably going to need at least half a page, depending on how much I decide to elaborate. Metallic is usually 1 to 2 boards. Ionic is definitely 2 boards, okay? And I'm going to hop back and forth between the boards. Covalent will only need 1 board. So it's really hard for me to estimate how much space you need. So those of you who get really angry with me if I don't leave enough space, I'm sorry. You might want to leave extra space in case I mess up.
Probably too much space.
I know, that's why I'm telling you ahead of time. I'm trying. I have a hard time estimating. And some of it will have really ugly drawings. I just don't know how to make it better. All right. I don't know if you want to write in pencil or pen. I'm just telling you what I'm doing. All right. So we're going to talk about metallic bonding first, and then I'm going to contrast it with ionic bonding. I'm going to save covalent for last because it's just really boring. All right. So let me make sure I haven't forgot anything before I jump to that. I think I've got everything, though. I don't think I forgot anything. I think I've done pretty good making sure I got it. Yep, did all that. Huh? Yeah. Nah, I'm getting old. I forget stuff. What if I asked you what the octet rule was? I don't think I've used that word. What do you think it is?
Nothing more than 8.
Being able to get the electrons in the, when you're forming a, I heard somebody say it, forming a bond, okay? Getting 8 electrons in the outer shell when you're forming a bond. Did that? Yeah, we're in good shape. All right, so a metallic bond. Just, nobody will remember it. All right, when we defined this way back on the very first day of bonding, I said this was the weirdest of the 3 bonds because this is often referred to as the electron C model, okay? And it's called the electron C model because the electrons are able to move freely, okay? They're not attached to any one nucleus. Okay? Now, that makes the metallic bond completely different than ionic or covalent, and it gives it unique properties. So, and I think you're the class I drew this really stupid picture for. All right, so if you consider this as a cross section of a metal, okay? Just think of this as a cross section of a metal, okay? If you have some miniature nucleuses or nuclei, and you have electrons, these electrons are able to move and go wherever it is they want to go. Okay? These are freely moving or mobile electrons. Now, no other bond that we talk about has that property because metallic bonds have mobile electrons. It allows metals in particular to be good. I want to say it was Jaden who yelled this out, but I can't swear to it. What did you tell me about metals? What property did metals have? That's right. That ionic and covalent compounds are not going to have. They're good conductors of heat and electricity. Okay? And I'm going to draw another tacky picture to go with this. And I meant to bring a battery today to replace in my conductivity tester, but as is typical in the morning, I get behind and the 9-volt battery went in one brain cell and out the other. And I completely forgot it.
Do you know what plastic is made out of?
Plastics, it's a polymer. So it's got a lot of carbon, hydrogen, and oxygens. But it's a repeating unit of something.
What are you gonna?
Freely moving what?
I'm trying hard to get to them, but normally I keep putting your quizzes and your homeworks and everything else in front of them. I keep hauling them around with me. So today, after I pick my son up from math tutoring, I'm planning to go home and make my children cook dinner so I can grade them. That's my goal tonight.
What's this?
Because I don't have anything from y'all. I should have one lab from 4th period and then that. That's my goal. Except I feel pretty crappy at the moment, so if I don't get any worse, that's my goal for tonight.
You did that.
I could.
What,
Okay.
what's this? Freely moving what?
What's what?
Freely-
Mobile electrons. They're moving, so they're mobile. A lot of times, test questions, we'll call them mobile electrons. That doesn't look any better. Try again. Normally I'm not this bad, but I've struggled with those. It doesn't help that I'm away from the house 3 nights a week. Next year my daughter will have her driver's license. I don't know who wants it worse, her or me. I suspect it's her, but I'm pretty desperate for her to have it too.
Until your parents be like, go to the store for me, go here, take here.
I am actually looking forward to that. I am looking forward to that.
Take this to your grandma. Take this here. I'm tired of drawing.
Yeah. The electrons move.
Yeah.
Anywhere or just next to it.
Right.
Next to each
I
other.
don't think
saying the
grandma
electrons
should be able to
just
drive.
Yes. No, they can move anywhere. Yeah.
No, give you like,
All right. So what do I mean by this? All right. My conductivity tester would have been a battery, but my 9 volts dead. All right. It has a light and a buzzer on it. It's got these 2 wires. So I would have taken it and laid it on a piece of metal. I would have used the water pipe. Okay. Now, when I laid it on this metal, if it was conductive, okay, light would come on. Okay? Now, what carries the current from this blue wire to this blue wire?
The electron.
The metal is usually the answer most people give me, but that's not the right answer. What carries it from one wire to the other? The electrons. These little electrons that are freely moving travel from there to there. Okay? Those moving electrons carry the electricity. Okay? Without those moving electrons, that light would have no chance of coming on. Okay? The metal itself does not carry the electricity. It's the fact that the electrons in the metal are able to move, right? When you have copper wiring in your cords or whatever it is you're using, those electrons are able to move throughout the wiring or the metal in the wiring that carry the electricity from point A to point B that allow it to operate. Now, what other properties do metals have? Oh, does everybody have that? That make it unique. That's somebody's phone or outside.
I thought it was a fire alarm. I thought it was like fire drill.
Let's hope not. All those people in the gym are going to be mad. Because I'm sure all those people are set up for the expo.
This month, I don't.
Yeah, for April, I think we have. I think. Maybe not. When was the last one? I think it was March. Because it would have been break. So it would have been March.
When do we have our fire drills? Is it
Usually the last day of the month. They're pretty close to the last day.
Last day, and then they'll do it again.
I had when they do them at 3:30.
Me too.
But that's so pointless.
Yeah.
Usually it's just to clean the building out. And then they'll lock the doors and won't let y'all back in. All right, everybody caught up now? All right, so if we go back here, what other properties do metals have besides being good conductors? Does anybody know? These are typical metal properties. All metals have these properties.
They don't heat up.
Huh?
They don't heat up.
Yeah, they will heat up. One starts with an M, one starts with a D, and one starts with an L.
Light.
Nope.
What are we looking for?
Joe.
L, D, and M.
I know in what context?
What metals are besides something?
Mold?
Matter.
You heard the word malleable?
No, I never would have guessed.
Okay. This can be rolled into sheets.
I said
Okay, rolled into sheets. Yes, like aluminum foil is very malleable. Okay. Ductile. Okay, ductile. Some people say ductile. Ductile can be drawn into a wire.
Isn't aluminum foil just straight up aluminum?
Yes, straight up aluminum.
why does somebody call it 10?
It might have been made of tin at one point in time, but and cans are made of tin, but I don't know.
My grandma calls it 10 for you.
And that's why I said I don't know. It may have been made of tin at one time, but now it's just made of aluminum. But a lot of older people will still call it tin foil. But most younger people will only call it aluminum. All right, and the last one is lustrous. Anybody heard the word lustrous?
Yes.
What's that?
It reflects light.
Or shiny. Okay? All metals are good conductors. They're malleable, they're ductile, and they're lustrous. Okay? Now, out of are we caught up?
Yeah.
Because I want to add a little bit more to this one.
Do we need these definitions for test or something?
Oh, yes.
What does malleable mean?
Malleable means it can be rolled into sheets. That was aluminum foil.
Not that.
Ductile means it can be drawn into a wire.
Yeah, but like I was just caught that.
Now, when we get down to van der Waals forces tomorrow, okay, you're going to need to know that out of the three bond types, that metallic bonding is the strongest of the three bonds. And if it's the strongest of the three bonds, it will have the highest boiling point. Okay? Because we're going to learn to rank boiling points and figure out whose boiling point is the highest and put them in order. Okay? So a metallic bond, being the strongest bond, will have the highest boiling point. Now, I think I remembered everything for metallic. You might want to leave one or two lines just in case I forgot something, but I think I remembered everything. Now,
But you said metallic is the strongest. So
yeah, it's the strongest, so it will have the highest boiling point. Almost. Now, I think I'm ready for ionic bonding tomorrow. I think. Put that there so we can talk about homework. Because I need to give you some instructions, or we really will have Xavier coming in tomorrow going, Ms. Wall didn't tell us how to do this, and I didn't know how to do it.
I'm gonna just skip first period and come here.
Okay. So, yes. Yes. It's not that much. It's just y'all are whining. All right. In part one. That's okay. I don't mind doing this one. In part one, you just got to write I or C. In part two, mark out number 5 and number 6.
Thank you.
You're going to need some instructions, genius. I already put mine up, so you're not going to know how to do it. Now, in number 1, and we're in part B. In number 1, you see where it has a little F with a dot? That's a negative sign. It's a little minus sign there, so you could read it. Okay? It's a -1 beside that first F. Okay, so it's F with a -1 and then just plain F.
On one.
A 1. Now, in the chart, the whole first row, out to the side, write dot diagrams. The whole first line of the table.
So CaONAB.
The line, the top row, are dot diagrams.
Atom of sulfur.
An atom of sulfur is a dot diagram.
Ion of nitrogen.
An ion of nitrogen is a dot diagram.
That's the low chemical correction.
Now, the second row are the chemical reaction pigments. Okay? Those are your ionic illustrations. Or chemical reaction thingies, to quote Tomas.
I actually wrote that.
Okay? You can write chemical reaction thingies if that helps you. So you're going to write Ca plus O yields for that first one. Okay? So, what's the last row?
All we gotta do is.
There's the Lewis structure. The bottom row is the Lewis structure.
Wait, so that was the This is the first one.
Y'all, a dot diagram for the love of God.
I thought.
Sulfur, a dot diagram. There's the first one. That's a dot diagram.
Which 5 and 6?
Now, the bottom, D. D is the one you need the most help with. Okay? It says A, X, and E. Y'all have no idea what these letters stand for.
No.
A is the central atom. X is just an atom. And E is a lone pair. Okay? A is the central atom. X is an atom. And E is a lone pair. So if you look at A, number 1, for example. If it says A with an X4, what geometry are we talking about if we have 4 atoms and it doesn't have any E's on it? Tetrahedral. Good. On the back, if it says bond polarity, what are you doing if it says bond polarity? Are we doing it with the 2 rules or are we doing it with subtracting with the chart? Subtracting with the chart. It says bond. Okay? F says molecule polarity. What are we doing?
2 rules.
2 rules. So what do you have to draw first to do the 2 rules?
A little structure.
Lewis structure and then the 2 rules. Everybody clear on the direction? Got it. I have no idea. I didn't design this sheet.
I'll be here in the morning.
Huh?
B, part
And
B.
then part B.
We don't do part B.
Part